Proxima Centauri b might have life. The second closest star to Earth after the Sun is Proxima Centauri, home to an exoplanet called Proxima b that is quite similar in size to Earth. Recently, astronomers found that it possesses ideal circumstances for supporting life. Could this exoplanet support life? Let's get going. Let's begin our voyage to the Alpha Centauri star system, where 3 stars orbit each other. Alpha Centauri A, the largest star in the system, is bigger, brighter, and older than the Sun. It belongs to the yellow dwarf category. Astronomers' calculations of the orbital characteristics reveal that Alpha Centauri A has a radius roughly 23% larger and 10% more mass than the Sun. The star Alpha Centauri A is located next to its companion Alpha Centauri B, which is very similar to Alpha Centauri A but smaller. These 2 stars are gravitationally linked and are separated from one another by 23 astronomical units, which is a very small distance when compared to the Sun's distance from Neptune, the outermost planet in our solar system. Both Alpha Centauri A and B may easily fit within our solar system. Astrophysicists believe it is quite possible that the 2 stars were created at the same moment and have always been gravitationally connected because of how near they are to one another. The 3rd star in the Alpha Centauri C system, also known as Proxima Centauri, is the star that is closest to Earth. It is currently 4.25 light-years away from our solar system and is expected to be just 3 light-years away in about 27,000 years. While this distance is still significant for human technology, it is significantly less than the distance between the Sun and the Moon. The most distant star in the system, Proxima Centauri, is currently 13,000 astronomical units from its 2 stellar partners Alpha Centauri A and B. It orbits Alpha Centauri A and B. Even at its closest point, every 500,000 years, Proxima Centauri approaches Alpha Centauri A at a maximum distance of 4,300 astronomical units. This is due to the eccentric orbit that Proxima Centauri takes around its 2 partner stars. Because of the characteristics of the Alpha Centauri system, scientists have concluded that it is most likely that Proxima Centauri was gravitationally grabbed by the Alpha Centauri system in the distant past, many billions of years ago, as it passed by the system. Next, Centauri. One of the planets orbiting the star Proxima Centauri is the one that steals everyone's thunder, Proxima b. This exoplanet was discovered using the radial velocity method, which showed that the host star, Proxima Centauri, periodically moved its Doppler spectral lines in a way that suggested an exoplanet was orbiting it. 2 spectrographs, the UVES at the Very Large 8-meter telescope and HARPS at La Silla Observatory, were used to make these measurements. The existence of the exoplanet Proxima b was confirmed on May 24, 2020, by a team from the Institute of Astrophysics of the Canary Islands and researchers from the Center for Astrobiology. They also found that it has 1.17 times the mass of Earth, is in the star's habitable zone, orbits Proxima Centauri in just 11.2 days, and has an orbital period of 1.17 days. To give you an idea of how close this is, Mercury is 0.4 astronomical units from the Sun, making Proxima b merely 0.05 astronomical units from Proxima Centauri, the star from which it is located. Does this imply that Proxima b has an arid climate similar to Mercury's or Venus? Strangely, Proxima b's orbiting star, Proxima Centauri, is significantly smaller than the Sun, therefore it does not appear that this is the case. Only 15% of the Sun's radius and 12% of its mass are found in Proxima Centauri. It is quite small and considerably colder due to the fact that its surface temperature of 2,725 degrees Celsius is less than half that of the Sun. As a result, Proxima b only receives 60% of the energy from the Sun that the Earth does. In addition, the habitable zones of each star varies according to the star's size. Although Proxima b is extremely close to its star, it is situated just within the habitable zone, one of the most important requirements for life, meaning that it is highly likely that life can develop on this world. Proxima Centauri is much smaller than the Sun, so its habitable zone is also closer. Conflicts in life. Proxima b satisfies one of the prerequisites needed to support life, but there are still a lot of additional conditions that need to be satisfied. In light of the fact that Proxima b orbits Proxima Centauri in just 11.2 days, we can assume with a high degree of certainty that this exoplanet's axis of rotation will be perpendicular to the plane of its orbit, there will be no stations, and that it will most likely exhibit a synchronous rotation, also known as tidal coupling. Tidal coupling is a phenomenon in which one body is gravitationally bound to another. As a result, one hemisphere of the world will always experience daytime, while the other will experience nighttime always. In this instance, the size of the planet's atmosphere will have a significant impact on its environmental conditions, if it has one at all. Moreover, of its makeup and the volume of water on its surface. We might be dealing with what is referred to as an eyeball planet if Proxima b possesses properties physically similar to those of the Earth. In this scenario, the hemisphere facing the star would be deserted, while the hemisphere at night would have an accumulation of frozen water if the amount of surface water were limited. Areas of permanent twilight might have the best environmental conditions for life as we know it under such conditions. We could be dealing with an ocean world that is entirely frozen outside of the area facing its star if the volume of water were significant, on the order of 60% of that of the Earth or more. The atmosphere exerted a surface pressure of the order of 1 bar, and nitrogen was the main component. Is Proxima b an ocean planet? If Proxima b is an ocean planet, we might encounter a world that is entirely covered in liquid water, has a similar range of surface pressures, the same volume of water, and a CO2-dominated atmosphere. On the other side, there would have been a runaway greenhouse effect with a higher atmospheric concentration of CO2. The exoplanet would therefore be an exovenus, or a planet that is equally inhospitable to life as Venus, our solar system's false twin, which, despite being the closest and having a size that is very similar to that of Earth, is the least suitable for life as we know it due to its sweltering temperatures. Proxima b might be 30 degrees Celsius 86 degrees Fahrenheit in temperature if it had an atmosphere, according to scientific speculation. It would still be minus 40 degrees Celsius minus 104 degrees Fahrenheit in temperature, even if it didn't have an atmosphere like our planet. In both scenarios, the temperatures are not so low, making it conceivable for life to exist there. Despite all the ideal characteristics that Proxima b has, scientists noticed something that could end any hopes of finding life on the planet, whether it is an ocean planet or an eyeball planet. Destroying solar flares. Astrophysicists have revealed that the star Proxima Centauri periodically releases enormous eruptions of plasma and radiation that would completely destroy Proxima b's atmosphere. Moreover, these eruptions would completely destroy the atmosphere in addition to eradicating all life. Some astronomers believe that if Proxima b's atmosphere is thick enough or has a magnetic field similar to our planet, it may resist these radiation eruptions. If Proxima b has a magnetic field comparable to ours, it may have a second criterion that makes it possible for it to host life. On Earth, the magnetic field created by the movement of the planet's core shields us from the dangerous and destructive radiation of the Sun. The European Extremely Large Telescope, which will be the largest optical telescope in history, will be the only means to determine if Proxima b has a magnetic field similar to the Earth, because it is now difficult, if not impossible, to do so. All of these are only conjectures based on models that may or may not be sufficient. Yes, an exoplanet with terrestrial mass that is situated in the perfect region to support life is in front of us, but it does not necessarily indicate it is habitable. In the case, the term habitable must be interpreted broadly in this context. A better definition for this kind of exoplanet may be a world with harsh environmental conditions that is uninhabitable for humans, but not, for instance, for some sorts of microorganisms. How do you feel? Do you believe Proxima b might contain the prerequisites for supporting life? Comment on this video and share your thoughts with us.